Today, what we're going to do is, or what I'm going to do in this tutorial is talk about can you identify various, how to integrate, what kind of properties you use, all right? What kind of strategy we use to solve different integrals. This is probably the number one thing that I get asked every single time I teach calculus. How do you know, Mr. Gutchuk, how do you know what strategy you're going to use? U-substitution, parts, partial fractions, trig substitution, so on and so forth. I'm hoping I'm going to break this down to something that's pretty easy. All right, because there's a list of different things that you want to do when you're going to try to solve these different integrals. The first thing is when you have to look at the problem. Okay, so when you look at it, you have to identify: can I solve this with a basic antiderivative? All right, is there a basic antiderivative? All right, all right. I'll just call anti right there. Okay, so basic antiderivative. Now looking at this problem, this is not a basic antiderivative. A basic antiderivative would be, for example, if I had the integral of 1 over x dx. Okay, that is what I consider a basic antiderivative. 1 over x is, well, hopefully you know, the natural log of x plus c, and that would be a basic antiderivative. Another one is a basic antiderivative. If I had 1 over the, all right, let's go to the third root of x dx. Well, that we can simplify to the antiderivative of x to the negative 1/3 power. All right, dx. And we would solve this using the reverse power rule of integration, in which we would add 1 here. So we have x to the 2/3, multiply it by the reciprocal of the power. So we would have 3/2. All right. And then we multiply it, and I'm sorry, not multiply, but we'd add c, and that would be the antiderivative of that. So you can see we have basic antiderivatives, basic integrals that we can solve. We come to this problem, and what you notice is you first see if you have a basic antiderivative. In this case, we don't. All right. We have this cube root, but we have 3x plus 4, which is not necessarily basic. It has something inside of the cube root. So if you find yourself saying, hey, I have something inside of something else, what we are going to use is what's referred to as U-substitution. All right, U-substitution. All right, U-substitution is when you usually have something inside something else. All right, something inside a function. That is what you're looking for. All right, and there are some processes in order we're going to use U-substitution. And that's what I'm going to talk about right now is how to use U-substitution. Because I think this is going to be a U-substitution problem. Because I see that I have 3x plus 4 inside of the cube root of the quantity. And it's in the denominator. So what we're going to do is we're going to basically use substitutions using reverse chain rule. Okay, so reverse chain rule. All right, reverse chain rule. All right. And chain rule is the breakdown of composite functions. So in this case, when we're using this, we're going to first pick our u. U value is what the inside function is going to be. So we're going to pick 3x plus 4, 3x plus 4. So we're going to take that. Now, when we have that, we're going to substitute the u inside for the 3x plus 4. What our goal is we're going to create an easier integral to solve. Okay, one of the basic integrals that we know right here. So I'm going to put u in there. Now, notice that we still have a dx left over. So we have to also eliminate this. So actually in U-substitution, there are 2 substitutions. One that you're plugging in for the values for u, and the other one we're going to take the derivative of this with respect to u. So I'm going to take the derivative of this with respect to u. You can see I was already starting to do that. The derivative of u with respect to u is going to be, oops. Yeah, it's going to be 1. Oops, what am I doing here? No, there we go. We have 1. All right, and right here it's going to be 3 du, or sorry, dx du, and then right here it's going to turn into 4. Okay, now I want to get all the u's and everything else on one side because I want to get dx by itself. So what I'm going to do is I'm going to multiply both sides by du, and I'm going to divide by 1/3, or divide by 3, not divide by 1/3, and what we have is dx equals 1/3 du. I'm now going to use that and substitute it in for my dx. So I'm going to have the 1/3, constant outside, 1/3 du right there. Hey, what did we just do? Well, we actually just solved and created a problem we just solved right over here. All right, x to the negative 1/3 power. All right, so I'm going to actually solve that now. I have the 1/3, which is a constant, comes along for the ride. And I'm going to write out this expression with u in it. So what I have then is going to be, all right, 3/2 u, remember we're using u, not x in this case, the 2/3 power, and that's going to be plus c. Now, to finish up the u substitution, we're going to plug in back in u. All right, and our u is 3x plus 4. So what we have is, I'm going to simplify this a little bit. Cancellation, it's going to cancel out. That cancel out. So what we have then, for the test de resistance à la fin, we have 1/2 times, what was it again? It was 3x plus 4. So that right there, 3x plus 4. That is what's going to be to the 2/3 power plus c. And you know, using the fundamental theorem of calculus, if we took the derivative of this, that should equal this expression right here, which you know what? It will. All right. And so you have it. That is when you use u substitution. So when a basic antiderivative doesn't work, you then try u substitution right away. All right. If that doesn't work, then there's parts and there's other things like that. But usually you try to hope that it's a basic or a u substitution. Okay. Well, I'm going to try one more. I'm going to give one more example, and then I'll stop this so you can see some other stuff. But all right, let's try this one. All right. Once again, you look at this problem, and you might not see what's going on. You see a t, you see a t squared plus 5. All right, well, let's see if we can figure this one out. All right, what I have right here is, once again, is there a basic antiderivative? I don't see anything basic here. The next thing is, can I use, oops, I'm sorry about that. Can I use u substitution? All right, u subbing. All right, u substitution. In order to use substitution, I have to pick a u, all right, that I would use, okay? Because remember, it's a reverse chain rule, so I'm going to see what I can pick. Now, generally, in our previous example, you saw that it was something inside. In this example, I don't have anything inside. However, notice that I have the denominator is greater than the denominator by, or numerator by 1. And usually for our u's, we usually pick either what's inside something, or sometimes I just pick the denominator. So I'm going to pick t squared plus 5. I'm going to see what happens here. Now, if I do that, I'm going to have t on top, and I have the dt. All right? And then I have u down here. Now, you might be wondering, well, I still have t dt. Well, remember, we have to take the derivative. Because remember, chain rule is you take the derivative of the outside times the derivative of the inside. So right here, I'm going to take the derivative of this with respect to u. So du dt in this case. Oops. Golly gee willikers, I am messing up. I apologize. All right. What we have, this turns into 1. All right. This turns into 2t dt du. The 5 turns to 0. Okay. Now, I'm going to get all this stuff. I'm going to get this over the other side. So I'm going to take this and I'm going to multiply by du. And then I have a 2t dt. And if you look right here, I need to get rid of t dt. Hey, I have a t dt here. And that's what you look for u substitution. First off, you take a u, and then if you take the derivative of that, do you get an expression that can replace the remaining part of your integral? Here we do. I just have to get rid of the 2, so I'm going to go 1/2 du, and that equals t dt. And so what we got here then is, substitute that in there, we have 1/2 as a constant, put on the outside, the integral of 1 over u du left over. Hey, that's a simple integral. That's one of our basic ones, and that's our goal. We're going to create a basic integral so we can solve this. So I'm going to solve this then, and we have 1/2 of the natural log of u plus c. But what is u? U is t squared plus 5. So our final answer is going to be 1/2 natural log of t squared plus 5 plus c. And that, my friends, is u substitution. All right. I went through 2 problems. All right. And hopefully helped you out how to identify when you would use u substitution. So I hope this helped you out. I'm going to put 2 more problems on here on how to use it. But good luck and God bless on the rest of your problems.